Here we have an arc length problem. What we have is a set of parametric equations, and we're trying to find the length of these parametric equations, this parametric curve, as the t ranges from -1 up to 4. So as t ranges from -1 to 4, you'll get various xy points, and those xy points will sketch out a curve. I just want to know how long that curve is. Fortunately, there's a formula that we studied in the last video that will tell us this. The arc length is given by the integral from a to b of the square root of x prime squared plus y prime squared, the derivative of x, dx dt squared, plus derivative of y, that's dy dt squared. Add those up, take the square root, integrate that from -1 to 4, and we should have our answer. So let's first of all find dx dt and dy dt before we plug them in. Dx dt, the derivative of x with respect to t would be 3, and dy dt would be 4t. So our arc length will be the integral from -1 to 4, and that's where t is ranging. That's why it ends in a dt. T ranges from -1 to 4 of the square root of dx dt squared, so that would be 9, plus dy dt squared, which would be 16t squared. So I have to do this integral, and the numerical value that I get when I'm done should be my arc length. Now the only thing I see about this guy, and this happens with so many of these arc length problems, is this is not really the nicest integral in the world to do. If I handed this to a Calc 1 student, what they would probably try is U substitution. That seems to be what would fit here because you have composition. But the problem with this is if you chose a U to be 9 plus 16t squared, as most of us would, then the du would be a 32t dt. And the problem is I can fix the 32 out front, but I can't fix the 32t. You can't add in an extra t. So this guy is just not very straightforward to do by hand, as most of these are not very straightforward. It is a definite integral though, so we can still compute this definite integral using our calculator. So let's finish it on that note. So let's pull up our TI here. Okay, and there, as you know, there's a couple of different ways to do definite integrals on your TI. I'm just going to go to the math menu and scroll down to number 9, which is a definite integral program that these guys have built into them. If you have an older version, if you have an 83 or an 84, you might have to look up the instructions on how to do this. I'm not going to go through it in this video. I've got it in one of my earlier videos as to how to do definite integrals on a calculator, an old type and a new type. But we'll integrate from -1 to 4 of, and then we'll take the square root of 9 plus 16. We don't need to see a t squared. It might as well just be an x squared. The lettering doesn't really matter. As long as we keep that same variable of integration at the end, so we'll integrate with respect to x. And so this is the integral I was trying to compute earlier that was somewhat challenging to do by hand. I push enter and I get an answer of 38.97 rounded. 38.97 rounded. So I will take 38.97, and this is approximately equal to this. So that's my arc length. The length of this guy from -1 to 4 would be roughly 40 units. Now, I'm not going to do it, but you're welcome to after you finish this video. One thing I like to do is I like to see, is this answer reasonable? I would recommend for you guys to take -1 and plug it in and get a point, and then take 4 and plug it in and get a point, and just see, are they roughly 40 units away, even in the ballpark? Because if you have a dot here at -1 and the dot at 4 is only just a couple units away, we must have done something wrong. Or if it's way too far, we must have done something wrong. But your intuition should tell you whether it's in the ballpark of 40 or not, which we did this one correctly, so I suspect it will be. So anyways, that's how we do arc lengths of parametric equations.